What up, Leviathan Nation? If you ran into this video, that automatically makes you part of the Leviathan Nation. So what I'll be demonstrating here, as you see from the title of the video, this is a series on object-oriented programming with Java. It's mainly for beginners. It will take you from zero to hero when it comes to understanding the principles of object-oriented programming. I'll code and you just need to follow along, and I'll also code some examples. Yeah, and if you have any questions, be happy to just leave a comment down in the video and I'll be happy to answer it. Okay, let's go. What is OOP? What is object-oriented programming? Object-oriented programming is a programming paradigm that structures software around objects, enabling modular, reusable, and maintainable code through concepts like encapsulation, inheritance, polymorphism, and abstractions. We'll touch a bit later on encapsulation, inheritance, polymorphism, and abstractions. But for now, we're gonna start with the basics of object-oriented programming. Our object. So what is an object and how do we create it? So an object don't just appear magically. We first have to create our class, and our class is like the blueprint of our object. So the class would usually have the properties, which are your fields or attributes, and it would also have a behavior, what you want, which would be your methods, what you want the object to do. Okay, so yeah, the next slide will have like an example of a class. Okay, let's go. Okay, so this is a dog class. So we try to have a dog object. Okay, so what are the characteristics of a dog? What does a dog usually have a name? So that's why we have the name attribute right there on top. And secondly, we have the dog constructor, where we will pass in the dog name and create the dog object. And thirdly, we have the sound, which is the method, what we want the dog to do. What sound does the dog do? Would bark. So the class is like the blueprint of what we expect the dog to do and the characteristic that the dog should have. So yeah, I'll show the example of how we can create an object from this class on the next slide. Let's go. Okay, so here we have our dog class reference, and Bobby, which will be the object reference, is equal to new dog. By saying new dog, we're creating an instance of the class, or we're creating the object. That's how we create an object, by the new dog. And as you can see here, we pass in Bobby as a string. The Bobby will be the name of the dog, and as you see below that, we have Bobby dot sound. The dot sound, we actually invoking the method dot sound. We're calling on the method, and when you call the method, we should have Bobby barks woof woof printed out on our console. And secondly, we have the dog reference again, Bella is equal to new dog, creating our object. Pausing in Bella is a string, and once we say Bella dot sound, we're actually calling that the sound method, and it will print out Bella box woof woof. Yeah, yeah. Methods are usually to do stuff, and yeah, here we're making a sound which is Bella box woof woof, and you can also access like the name property or attribute of the dog object, but I will touch on that on our next example where I'll code this example and talk more on the concepts and stuff. Okay, let's go. Okay, yeah, we're back again. Now we will be coding the examples that we had on our slides. You can follow along on your IDE, or you can just watch the video. Yeah, the choice is up to you. I'm currently using IntelliJ, but you, the viewer, you can use any IDE that you feel comfortable with. If you decide to follow along and code with me. If you are new and you don't have an IDE installed on your virtual machine, that's nothing to worry about. I'll have a link at the description section of the video where you'll be referenced to a video that will guide you on how to have IntelliJ set up on your virtual machine. Yeah, but for now, yeah, let's code the examples that we had on our previous slide. But before we do that, let's just test out our main class, because this is the class that we'll be using, and make sure that it's working. Yeah, when I run the main class, I expect it to print out. Okay, let me just put that there. I'll expect it to print out hello world. Lovely. Seems like it's working. We have hello world printed out. And now let's go back to the slide examples that we had. So we said that we wanted to create a dog object. That was our main goal. And a dog object would usually have dog properties or characteristics, and it would also be able to do things that the dog could do. Yeah, now we'll just code that, but for us to get to an object, we first need to have a class, and that's what we'll be doing now. Yeah, let me create a dog class. Okay, doggy. Okay, and let's say string, and add our name attribute, and then our constructor, which will take in the dog name. Okay, and assign it to our name attribute. Okay, to our name attribute. Lovely. Yep, and then we'll have our method, which will be the dog doing his thing, barking. Woof woof. Okay, let's use our name attribute and say dogs. Oof. Yeah, so yeah, this is our class, right? As we discussed on the slides, our class usually have dog characteristics and dog, yeah, anything that a dog could do should always be at the dog class, because a class is like a blueprint of our dog. So yeah, that's what we're doing now, and that's what we did. Yeah, so now let's go to the main class and test out our dog class and try to create a dog object from that. Let's say dog Bobby. Let's use, yeah, Bobby as our reference. Let's say new dog and pass in Bobby as the name, and then yeah, let's see what happened when we try to invoke the sound method. Let's see if Bobby actually barks or not. Oh wow, Bobby barks. Woof woof. Ah, there we have it, our object created. And yeah, let's see if we can access the name attribute in our dog object. I didn't show it at the slides, but yeah, currently showing it here. Okay, how can we do that? Let's just say, let's just do this and say the dog name is, okay, dog name. Now we're trying to access the name attribute. We should have the dog name is Bobby printed out. Let's put that to a test. Okay, let's run this. Oh, lovely. The dog name is Bobby. Bobby barks, woof woof. Yeah, let's create a second object. Okay, we can name this Bella is equal to new dog, passing Bella as our name, as our dog name. And yeah, let me just copy this. Let me just copy this, and yeah, just use the Bella reference, and yeah, the Bella reference to get the sound that Bella makes. So yeah, I'd expect us to have the dog name is Bella, since we pass in Bella as the dog name, and we're trying to access that attribute. And then when we want Bella to make a sound, we should have Bella barks woof woof printed out. Let's put that to a test. Okay, lovely. The dog name is Bobby. Okay, looks good. Bobby barks woof woof. Yep. Since we're trying to invoke the sound method, the dog name is Bella. Okay. Yep. Bella barks woof woof. Perfect. Yeah, we've created, yeah, our objects, and yeah, this will conclude our object section. Now we're going into the real stuff. Yeah, the next part we will touch base on encapsulation. Yeah, let's get it. Okay, Yeah, so we're back again on what is encapsulation. Encapsulation means keeping your object variables private and controlling how they're accessed or changed through the use of getters and setters. In encapsulation is achieved through the use of access modifiers um, in Java. So Java have access modifiers, which are keywords that play a very crucial role when it comes to object-oriented programming. Without Java access modifiers, it will be quite hard to achieve object-oriented programming. They play a very important role in it. I'll touch base on access modifiers on the next slide. Okay, so what is Java access modifiers? Java access modifiers are keywords that control where a class, variable, or a method can be accessed from. So these keywords, they determine where a class or a variable or a method can be accessed from. So we have 4 Java access modifiers. We have your public modifier, you have your private modifier, you have your default modifier, and you have your protected modifier. The public modifier means that whatever has the public keyword in Java can be accessed from any package and any class, and whatever has the private keyword or modifier means that it can only be accessed within the class it is specified at. You can't access it outside the class, you can only access it inside the class itself. And you have your default access modifiers. Default access modifier, the default access modifier means that you can only access that variable in the same package. You can only access that variable in the same package. You can't access it on other packages. So what is a package? A package in Java is like, for our new beginners, for people that are not quite familiar with Java. So packages is like folders that we have inside our project. So these folders help us manage our project. For example, we'll have like a user folder. The user folder will have classes that are related to the user, or user functionalities. And we also would have maybe a finance package, which will act as a finance folder, which will have all the things, all the classes that have finance related functionalities. It's just a way of managing your project and separation of concerns. And the more your project grows, the more easier it is for you to navigate your project and know where to find what and what, because like you can't just have classes anyway. It becomes quite messy. The bigger your project grows, the bigger your project gets, you want to be able to know exactly where to find which class. You don't want to struggle through a bunch of classes that are maybe only kept on the same package. You want to have like proper package names. which is proper folders to manage all these classes, like as I said before, finance package to manage finance related classes, maybe a user package to manage user related classes. Yeah, it makes your job quite easy. So yeah, so the default means that that variable can only be accessed in the same package, by the classes in the same package. Classes on other packages, they won't be able to access that variable. And then we have our protected modifier. So the protected keyword or modifier means that you can only access whatever you specified as protected in the same package, and also your subclasses. And we'll touch later on subclasses when you talk about inheritance and stuff. Yeah, but yeah, protected modifier is only meant for things that you would want to access in the same package or your subclasses. Okay, let's do next. So an encapsulation example would be a bank account. So we have our bank account clause, and our bank account clause have the balance. So a balance is the amount of money that you have in the bank. So that's super private. You wouldn't want anyone playing around with that. You would want to have restricted access as much as possible with the balance. That's why we have the balance attribute as private. You see the private keyword, and then you don't want anyone to mess around or access the variable from anywhere to update it. So that's why it's private. And below that we have get balance. We've made it public because we want people to be able to get their balance, but yeah, we don't want them to actually update the balance. Yeah, but we want them to update the balance, but it should only be done through a deposit of money. So that's why right below we have the deposit method. The deposit method, what it does, it takes the amount that you've paused in and add it to the amount that's currently in your bank account. And as you see in the deposit method, there's a check to see if your amount is above zero, because when you're depositing money inside your bank, we wouldn't want any negative value. That don't make sense. So we want any value that's above zero, and then we add it to your current balance. So this was a good example that I can think of when it comes to encapsulation. Let's go on to the next slide. So why is encapsulation so important? So it's important for security purpose, control purpose, flexibility purpose, and clean code purposes. So that's the benefit of encapsulation. Next we'll be coding. We'll code the example and touch more on encapsulation when I'm on the coding process, so stay tuned. Okay, so now we'll be coding the example on encapsulation, using the bank account as an example. Bank account would usually have a balance, private double balance link. Constructor. Now, since a balance is a very sensitive attribute, you wouldn't want anyone to be able to access it from anywhere in the code or make any funny alterations in the code. We always want to have control on how the balance is updated, and that control we always try to keep it inside the bank account clause, so that to have clean code. Yeah, you don't want to have that functionality at a different place in the code. So yeah, another method we would most likely want to have that will call from anywhere is the get balance method. We should be able to get the balance, how much money is in the account from almost anywhere. We should also be able to deposit money inside the account. So let me create a public void deposit method. The amount that you want to deposit into our bank account. So let's say balance and add amount to whatever is in the bank account. But when it comes, we should also validate amount is bigger than 0. Yeah, because it wouldn't make sense for someone to want to, it wouldn't make sense for someone to deposit a negative amount. It should always be a positive amount. So this is the validation that I was talking about, and making sure we're keeping all the amount validation and logic inside the bank account clause. That's also a big part of encapsulation. It meaning that when we deposit money, when we call the deposit method, we can easily call it from the main clause, and there will be no additional code needed to do any validation checks, since everything will be inside this bank account clause. This makes our code a whole lot cleaner as well. Yeah, so okay, let's do an example. Let's test our code out. Okay, let me do this. Bank account here. Bank account. So okay. Let me do this. 100. And get balance, and see if passed in 100 as our balance. Yeah, now we're not worried about, okay, I'm sure some of you are wondering, okay, what about the currency? Currency. Yeah, now we're not worried about the currency. Yeah, we're just trying to test out the balance variable. But yeah, in a proper software or proper functional project, you would also want to have your currency also inserted what your amount. Yeah, so but for now this is different. This is just for demonstration purposes so that's why we're not putting too much effort on that. But yeah, let's test it out. Okay, lovely. See, we have 100 in our bank account, and then let's see if we can actually deposit. Let's try to deposit 2,000 rand, and then try to call and try to get a balance and see what happens if we try to deposit a negative 2,000 rand. As I've said before, we shouldn't allow the deposit. We shouldn't allow someone to deposit a negative amount. So I expect the balance to always stay 100 since we're not allowing that. As you see here, we always check the amount that is being deposited to see if it's actually bigger than 0, and if it's bigger than 0, then allow the amount to be deposited inside our account. But this one is negative, but let's test it out. Okay, let me say current balance, and then here current balance after negative deposit. Current balance 100 rand. Okay, or dollars can be anything, or euros. Current balance after negative deposit still 100 rand. Okay, then let's try to insert the positive amount, 2,000. Deposit 2,000 now. Okay, current balance after positive deposit. Okay, let's test it out. Let's run this main method. So see, now we have 2,100 inside our bank account. Yeah, lovely. So yeah, that concludes our demonstration and example on encapsulation. Now you're gonna have a look at inheritance. Please stay tuned. We're back again, nation. So we're back on inheritance. So what is inheritance? In Java, inheritance allows a subclass, which is the child class, to inherit fields and methods from a superclass, which is the parent class, making it easier to reuse code and avoid repetition. So inheritance allows us to not create duplicate code. It allows us to easily inherit certain functionality from maybe a superclass, so that we don't end up in a loophole of repeating ourselves as we build or scale our software. So let's go on to the next slide. We'll touch base on a inheritance example. Okay, so yeah, so this is our inheritance example. We have our superclass, which is the animal. As we see there, we have our protected variable, which is the name. So we expect all animals to have a name, and we also have a protected method, which is eat. We expect all animals to be able to eat at least. As we see now, we are using the protected Java access modifier. So the protected Java access modifier allows the field or method to be accessed by subclasses. So the name will be able to be accessible to the subclass of the animal class, and the eat method will be able to be accessible at the subclass of the animal class. So below we have our subclass, which is the dog. We extend the animal class, so the animal class already comes with the name attribute and the quality of eating, which all animals should have. And then we just needed to add the sound dog box. And that's it. And you could also do a whole lot. Here we only added the subclass of a dog. You can also take it for and maybe have a subclass of a cat that also extends the animal superclass, and you can have access to the main attributes to the eating method without having to re-add those methods on the new class, which would be maybe your cat class, if you get what I mean. So that's conclude the description of inheritance. The next phase will be me coding this example and talking about it even further. Please stay tuned. Thanks. Okay, Nation, we're back again with an example on inheritance. Start off by writing code for the example that we had on our previous slide and add a bit of more flavor to those examples. Okay, let's start with the animal class, which will be our super class. Animal class, and say protected string name. So I'm using the protected modifier because the protected modifier is a modifier that allows whatever have been set as protected to be accessible at the subclass level and inside the package, and to classes inside the package where it's used. And since animal is our superclass, whatever class that has the animal class extended as a superclass will automatically inherit this name attribute. And it's also add a method protected food eat, since we expect all animals to eat. Once we call the eat method, we should say name is eating good. So this is our super class. And let's create our subclass, which would be our dog. Extend animal So by extending animal, I automatically have access to the name attribute and the eat method. But since a dog is unique, I would want to add maybe a method where I say bark since only a dog have a unique capability, which is the barking capability. Say dog name is barking woof. Yeah, so as you see here, I could access the name property automatically just because I extended the animal class. Same as the method, I can also access it since I've extended the animal class. Let's not stop there. I can also create a cat subclass and extend animal and a cat have a what's unique about the cat. Okay, I can add public food meow. Okay, so cat meows. So say the name attribute, try to access the name attribute from the animal superclass is meowing all the time. Yeah, so yeah, let's do a bit of testing in our main class. Okay, let's say dog equal to new dog, and let's set our dog name to Bobby. Yeah. Yeah, Bobby is the name that comes to mind. That always comes to mind when I'm doing this. And then let's try to print out some stuff. Let's see if dog, try to print out the dog name. Our dog name is and set dog point eat. Okay. I'm sure. Oh yeah, it's a void. I can't have it. Yeah, so I'll just say dog point eat and say dog point walk. The eat is the method that we have in our superclass. We can see here we can easily access it on a dog, a subclass, and then let's run our code and see what's up. See, our dog name is Bobby. Bobby is eating good. Yeah, Bobby is barking woof woof. Let's now use an example of our cat subclass. It's equal to new cat. What's a cat name? What's a good cat name that I can think of? What's a good cat name? What can I say? Okay, just say Mickey. Okay, yeah, Mickey. Yeah, that's what I'm currently thinking of. So that's the name I could think of. So I'll just say our cat names cat dot name, and then cat dot, let's see what we can do. What happens when you invoke the eat method? Should I have Nikki eating good? And what happens when you invoke the meow method? Have the meow printed out. Okay, let's put that to test. Lovely. We have our Bobby. Okay, let me just do this sound just to have some space here. Perfect. Yeah, so yeah, Bobby. Our dog name is Bobby. Bobby's eating good. Bobby's barking woof woof. For our cat subclass, our cat name is Nikki. Nikki is eating good. Since we expect also Nikki to be able to eat. Nikki is meowing all the time. You know. Yeah, and yeah, that's it. Yeah, so that concludes our run on inheritance. Yeah, please stay tuned. Let's go. Okay, nation, we're back again with polymorphism. What is polymorphism? Polymorphism means many forms and happens when related classes use the same method in different ways. Inheritance allows classes to share methods, and polymorphism lets those methods behave differently. A good example of this would be like having a superclass of animal and having a method at that superclass which is make a sound. At the superclass method you might just have like at the animal class you might have animal making sound printed out. But if you create a dog subclass and extend the animal superclass, you might want to re-implement the make sound method and override the already implemented methods of your superclass, and instead of saying animal make a sound, you can say the dog barked woof woof. And then for a cat subclass you can also override the default animal make a sound method with saying the cat is meowing whenever the make sound method is invoked. Yep, that's how polymorphism work. Yeah, but that's not it. We also have a next slide with some examples on polymorphism. Let's go. Yeah, polymorphism example. We have public class animal with the method eat. Animal name is eating good. That's like our default functionality that we wanted to go with. So whatever subclass inherits the animal method, well, when they invoke the eat method, they will have the animal name is eating good printed out. But in polymorphism we can actually override the eat method with a different and make the eat method behave differently than the superclass function than the superclass method. And as you see below, we have the dog subclass that extend the animal superclass. Instead of having animal name is eating good, now we will have the animal name is eating dog food. It's completely different from our default eat method at our superclass. So when we create a dog object and invoke the eat method, what will be printed out is the animal name is eating dog food. And for a cat, we also did the same. And instead of going with the default animal is eating good of the superclass, we will go with animal is eating cat food. You see, it's we overriding the method and having it do something different than the default, since it makes sense. Since we expect the dog and the cat to eat different food, that's why we went with we overwritten the method and made them behave differently. We'll also be coding this example next, and I'll share more on this matter as on the next phase. Okay, yeah, that's it. Yeah, let's go. Yeah, it's time to code our polymorphism example, put it to a test. Yeah, let's have a look here and see. Yep, we have our eat method, our default eat method, which is animal name is eating good, and then we have our overridden our eat method, but we've overridden the default one. Instead of having animal name is eating good, we will have animal name, which is the dog name, is eating dog food. And for the cat, we also did that. We overridden the eat method, and now we'll have cat name is eating, okay, it's supposed to be cat food. My bad. Yeah, is eating cat food. Yeah, so let's put that to a test. Okay, let me say dog, continue dog name is puppy. Okay, dog dot eat. So now we expecting to have Bobby is eating dog food printed out. Let's do that. Lovely. Bobby is eating dog food. We have it printed out. But let's see what happens when we remove it. We will go to the default eat method, which is at our superclass, which is Bobby is eating good. Yep, went with our default one, but that's not what we want. We want to have a unique functionality for the dog eating method, so that's what we have. Okay, let's print it out one more time. See, Bobby is eating dog food. Okay, let's test the cat out can say if the cat is eating cat food. So cat dot name equal to cat dot eat. So just a space in between. As you see, Nikki is eating cat food. We've overridden the default eat method, which was supposed to be Nikki is eating good. Now we're saying Nikki is eating cat food instead. Yeah. So yeah, that concludes our example on polymorphism. Next, we'll be looking into abstraction. Yeah, let's go. What is abstraction? Abstraction means hiding complex details and showing only what is necessary. In Java, this is done using an abstract classes and interfaces. Abstract classes cannot create objects directly, and abstract methods have no body, so they must be implemented by your child class. So if you use an abstract method usually have no body to it. You will have to implement it at the subclass level. It's usually added at the abstract class. So yeah, this is more of a more technical preview of what abstraction is. The next slide is more of a less technical description of what abstraction is. So abstraction, you can also define it as this is the process of hiding the internal details of how something works and showing only the essential features to the user. It helps you focus on what an object does, not how it does it. The idea is you define what should be done in the abstract layer, which can be your abstract class or your interface, and the actual implementation is done in the subclass. You just define what you expect the class to do at the high level, and then you implement that functionality at your subclass. So abstraction example, so there we have our animal. So we expect all animals to make at least a sound. So as you see, this is an abstract method. It has no body to it, and an abstract animal class, meaning that you can't create an object out of it. You can only extend it to a subclass. And below we have our subclass, which is our dog. It extends the animal abstract class, and then we are forced to implement the logic of the animal sound, which is dog barks, woof woof. And for a cat subclass, we will maybe say the cat meows, meow meow, something like that. That concludes our overview of what abstraction is. Next, we will dive into the code and just try to code it out and talk about it more. Okay, let's get it. Here we go with the conclusion of abstraction in object-oriented programming. in Java. Yeah, this is our last example, coding example. Here, as you see, we have our animal abstract class, and we also have an abstract make sound method, meaning that every subclass that implements this abstract class, we expect it to have a unique sound functionality to it. Like a dog would have like its unique sound that it would make, which is barking, and a cat would have its unique sound, which is meowing. Yeah, let's have a look at the dog subclass that extends the animal abstract class. You see here we've overridden the make sound method, and whenever we call the make sound method, we should have the dog is barking printed out. And let's have a look at the cat subclass that extend the animal abstract class. Whenever the make sound method is called of the cat class, we should expect the cat keeps meowing printed out. Okay, let's put that to a test. Cat, say dog. Your dog. Dog don't make sound. Let's see what happens. Lovely. We have the dog is barking printed out. And then let's look at the cat. New cat. Let's see what sound does the cat make. The cat keeps meowing. So yeah, this is abstraction, ladies and gentlemen, and that concludes our series on object or on OP, object oriented programming. Yeah, if you're new, please hit the subscribe button. I'll be posting more content similar to this, and a whole lot of cool content is on the way. Please hit that subscribe button so that you can stay tuned and you can be notified whenever I post new content. Okay, yep, that's it. Yeah, thanks for staying this long up until the end of the video. Really appreciate it. Peace out.